Our lesson today is talking about special right triangles. We have two types of special right triangles. The first one is 45, 45, 90 degrees, and second is 30, 60, 90 degrees. We'll talk about the first one, 45, 45, 90 degrees. Okay, we know that if we have any triangle, right, and that angle 45, and that one 45, and that is A, B, C. That is isosceles triangle. We have two angles are equal, so the two sides here must be equal. For example, if that side is 5, that one will be also 5. And using Pythagorean theorem, we can find AC. It will be 5 power 2 plus 5 power 2 under root. It will be 5 root 2. So in general, if we have here any side like 5, that will be 5, that will be 5 root 2. If that one 6, that will be 6, that will be 6 root 2. If that one is 8, that will be 8, that will be 8 root 2. In general, that is our triangle 45, 45, 90 degrees. If that one is x, that will be x, and that will be x root 2. That is the rule. So that is the first type. It's called 45, 45, 90. If that side is x, that will be x, that will be x root 2. Second one is 30, 60, 90 degrees. That is our rule. The side opposite to 30 is x. So the hypotenuse will be 2x, and that side will be x root 3. From where that rule, keep attention with me. If we have equilateral triangle, A, B, C, that is equilateral. It means all sides are equal and all angles are equal. All of them 60 degrees here, here, here. So if we make perpendicular from here, it means that part is 30 degrees and that one 30. If AB, all of it 10, that side will be also 10, and that one will be 10 because it's equilateral triangle. So if AB is 10, BC will be 10, so that part will be 5 and that will be 5, and that is also 10. If we remove the part, so that is our second type, 30, 60, 90 degrees. If that side 5 opposite to 30, the hypotenuse will be 10, and that side will be 5 root 3. So if that one 6, that will be 6 root 3, and that will be it's twice 12. So in general, that is 30, that's 60. That side opposite to 30, if that side is x, that will be x root 3, and that will be 2x. And that is our second special right triangle. Here, if that one is x, that will be x root 3, and that will be 2x. For example, here, and that triangle is 45, 45, 90, so we will talk about that special case. So the hypotenuse here is 10, it's x root 2. So 10 here equals x root 2, and that is x and that is x, like the rule here. From here I can find the value of x. Make an equation divided by root 2 So that side AB, AB, AAC equals to BC, both equals to 5 root 2. Okay. Again, another one. That triangle is 30, 60, 90. So we are talking about that triangle, that special triangle. So the side opposite to 30 is x. So that is x. So here that is x. So that one is x root 3, and that is 2x. So we can write DE is 2x. So it's equal 10 root 3. That is DE. Okay. How to find DF? How to find DF? Here. DF is x multiplied by root 3. So root 3 multiplied by root 3, it's 3. Multiplied by 5 equals 50. That is it. Okay. That is it. Another example. Here. That is 30, 60, 90 degrees. So the side opposite to 30 is x. Here x, and here x root 3. And here, I'm sorry, and that is 2x, and that is x root 3. Again, that is x, that is 2x, and that is x root 3. From here I can find the value of x. I will put 2x equals 4 root 3. So I will write 2x equals 4 root 3. Divided by 2, so x equal 2 root 3. So here, that side is 2 root 3. And that side is 2 root 3 multiplied by root 3. It's equal 6, because root 3 multiplied by root 3 is 3. Multiplied by 2, it will be 6. Okay? So that is 2 root 3, and that is 6. Okay. What about that one? That triangle? It's 45, 45. So that is x, that is x, that is x root 2. That is x, that is x also, and that is x root 2 multiplied by root 2. So here it's equal root 6 multiplied by root 2, root 12. Root 12 is 2 root 3. Multiplied by 2, it will be 4 root 3. 4 root 3. Again, the part from where? Again, the part from where? It's x root 2. How to multiply? Yeah, multiply root 6 by root 2, it's root 12. So it's 2 root 12. And root 12 is, that is 2 here, and root 12 is 2 root 3. So it's equal 4 root 3. Okay. Okay, explain number 2. explain number 2. It's talking about the sine and cosine and tan for 45 and 60 and 30 degrees. For example, if we have triangle 45, 45, 90 with a leg equals 1, so that is 1 and that will be also 1, and here we see before x root 2 and x is 1, here x, that is x, that will be x root 2. X is 1, so it will be root 2. Okay, so from here I can find the value of sine 45 equals opposite over hypotenuse. So it's equal, the denominator can be root, so I will multiply by root 2, multiply by root 2, so it will be root 2 over 2. So our sine of that angle is root 2 over 2. And the cosine is also root 2 over 2. And the tangent is 1. Why 1? Because it's opposite over adjacent. 1 over 1 equals 1. Okay? If you want to talk about the second triangle, 30, 60, 90 degrees, and our side is 1, here the shorter side is 1, so the hypotenuse will be twice x. That is x, that is 2x, and that is x root 3. It's root 3. From here I can find the value of sine 30 and cosine 30 and tan 30. How? Look at me, I took it before. Tan 30, for example, is opposite over hypotenuse, so it's 1 over 2. That is it. And out of an cosine, I'm sorry, I'm talking about sine, not tan. Sine 30 equals opposite over hypotenuse, so it's a half. So that is our sine and that is our cosine with the same steps, and you can find tan for 30 and 60. Okay, so we can solve number 9. Here you told me that is 10. We have 45, 45, 90. So that is 10 equals x root 2. From here we can find the value of AB. How? It's x and that is x. Find x first. So x root 2 equals 10. From here, x root 2 equals 10. Because the rule of 45, 45, 90 is x root 2. So x root 2 is 10. From here I can find the value of x. How? By dividing by root 2. So x will be 5 root 2. So that side is 5 root 2 and that will be 5 root 2. From here you can find any ratio you want, sine or cosine or tan, for 45. But remember, we said before that sine, any angle, doesn't change whatever the numbers we have. So sine 45 will be always root 2 over 2 and tan 45 will be always 1. And the cosine will be root 2 over 2. Whatever the numbers you have. Okay, and if you want to check using these numbers, you can check. The last part, you can read that part, Pythagorean triple, that part, but you can solve these problems without using that information. Okay, how to solve that one using Pythagorean theorem? You took it before. You told me here verify that 3 and 4 and 5 are Pythagorean triples, or 3 and 4 and 5 can form right triangles. Okay, how? Look at me. Told me 3 and 4 and 5. We will add 3 and 4 but power 2. If they are equal, 5 power 2, the greatest one power 2, it means that we have Pythagorean theorem. So it's right triangle. Okay, if they aren't equal, it means that we haven't right triangle. Another example. Another example here. He told me 5, 12, 13. Okay, 5, 12, 13. 5, 12, 13. Okay, we will find 5 power 2 plus 12 power 2 if they are equal. The greatest one, and they are already, using calculator you can check. So we have right triangle. Yes, they are equal. 5 power 2 plus 12 power 2, it's equal 169. It's equal to 13 power 2. Okay, and with the same steps you can check 13, I'm sorry, 7, 24, 25 here. That is 7, 24, 7 power 2 plus 24 power 2, it's equal 625. It's equal the third one power 2, the greatest one. So it's right. Okay. The last problem, using Pythagorean theorem. It's not important to use Pythagorean triples here. How to find the unknown side, that side. It's 18 power 2 plus 24 power 2 under root. You can do it. You took it before. So I will write PR equals root. We will put 18 power 2 plus 24 power 2, and you can use your calculator and find it. It's equal 30. And the last one, using same steps, that is hypotenuse, the greatest one. So I can find any side using that rule. 68 power 2 minus 32 power 2 equals 60. That is the third side, YZ. Okay. Again, if you want to graph triangle to make it easy for you, the hypotenuse is xy is 68, and that is z, and he told me that xz is 32, that is 32. So how to find yz? It's using that rule. And thank you, that is it.